Good morning to everyone. Welcome to Power Electronics tutorials by Wali Sheikh. In this tutorial, we are going to discuss about concept and types of commutations. Coming to concept of commutation. The concept of commutation is exactly opposite to the concept of triggering. Triggering is nothing but the process of turn on the SCR. Commutation is the opposite to the triggering, means the process of turn off the SCR is nothing but commutation. Here commutation can be achieved by making the current flowing through SCR to 0, or by making the current flowing through SCR is less than the latching current. Here latching current is the minimum amount of current required to turn on the SCR. By making the current flowing through SCR is less than this minimum current, then SCR comes into off state, and this process is called commutation. Coming to types of commutations, commutations are mainly classified into two types, that is natural commutation and forced commutation. The concept of these two types are very simple. Now we are going to discuss about what is natural commutation and what are the applications of natural commutations. Similarly, what is forced commutation and what are the applications of forced commutations. Coming to natural commutation, the name itself indicates the meaning of this type of commutation. That is the commutation in which SCR can be commutated or SCR can be turned off naturally. Means without using any external components, SCR comes into off state. That type of commutation is called natural commutation. That is this one. SCR is naturally or automatically comes into off state. That is nothing but natural commutation. This natural commutation process is possible if the input is AC. That is nothing but this one. This is the AC input. If we consider input is AC, this input becomes 0 for every half cycle. This is the first half cycle. After completion of first half cycle, the input becomes 0. Similarly, after completion of second half cycle, the input becomes 0. Similarly, after completion of third half cycle, it becomes 0. Means if the input is AC, that AC input becomes 0 for every half cycle. If the input is 0, means the current flowing through SCR becomes 0. If the current flowing through SCR becomes 0, then SCR automatically comes into off state. That's the concept of natural commutation. Coming to application, natural commutation is mainly used in rectifier circuits. Here rectifier is nothing but it is a circuit which converts AC to pulsated DC. AC to DC. Here in rectifier circuits we are using the input is AC, means this one. So every half cycle it becomes 0. That is input becomes 0. Same this process. Input becomes 0, then current flowing through SCR becomes 0, then SCR automatically comes into off state. That's the concept of natural commutation and application of natural commutation. Coming to second type of commutation, that is forced commutation. This commutation is exactly opposite to the natural commutation. In natural commutations, SCR can be commutated without using any external circuit. But in this commutation, by using some external circuits, we are going to commutate the SCR. That is the commutation in which SCR comes into off state by forcing or by using some external circuits. That type of commutation is called forced commutation. This forced commutation is possible if the input is DC. That is nothing but this is the DC input. If we consider input is DC, this DC input never comes to off state. It never comes to 0 state. By using some external circuits, we are going to force this input, this DC input to 0 state. That is, by using some external circuit we are going to make the input to 0. This is magnitude of DC. By using some external circuit or by forcing, we are going to make this DC input to 0. If the input is 0, then the current flowing through SCR becomes 0. If the current flowing through SCR becomes 0 means SCR comes into off state. That's the process of forced commutation. Coming to applications, this type, that is forced commutations, are mainly used in choppers and inverter circuits. Here chopper is nothing but the circuit which converts fixed DC to variable DC, means in this input is DC. Similarly, inverter is a circuit which converts DC to AC. Here also input is DC. This DC input never comes to 0. So by forcing we are going to make these DC inputs to 0. By making the DC input to 0, the current flowing through SCR becomes 0. Then SCR comes into off state. Depending upon the type of the circuits we are using for making the SCRs to commutate, forced commutations are mainly classified into 6 types. That is from class A to class F commutations. Here class A commutation also known as resonant commutation. Similarly, class B commutation also known as resonant pulse commutation. Class C also known as complementary commutation. Class D also known as impulse, parallel capacitor and voltage commutation. Class C also known as external pulse commutation, and class F also known as line commutation. Here from class A to class E we are using input is DC, and for class F commutation we are going to use the input is AC. These are the types of the forced commutations. This is about the concept and types of commutations. In the next tutorial, we are going to discuss each and every type of forced commutations. Thank you.